Okay guys, I just want to go through this completing the square technique we were doing, because it's easy just be able to do it, but I want to discover why we do it, okay, and how we can do it, and to give a visual representation of actually what it looks like. So I'm just going to take an equation or a function here, right? So this function is x squared plus 6x plus 9. Now if I was to factorize that out using your guide number or your minus b formula, or just to factorize it out, you'd get two answers, x minus 3 and x minus 3. Okay, sorry, actually it's x plus 3 and x plus 3. Okay, so just think of it that way. If you factorize that out, you will get these answers. Now you'll notice the two answers are the same. If the two answers are the same, then that means the graph cuts the x-axis in one place. Okay, and I can rewrite that as x plus 3 squared. Okay, and what that is telling me is that this graph here cuts the x-axis in one place. If I had two different answers, then the graph would cut the x-axis in two places. Now what I'm going to do is I'm going to draw this graph, or this equation, onto this graph in the domain minus 5 to minus 2. So basically I'm going to put in minus 5, minus 4, minus 3, minus 2, minus 1 in for x, see what it spits me out, use the 2 points, the x and the y, to get a coordinate, and then plot them. So when I put in minus 5 in for x, I work it out and it spits me out 4 for y. So the point is minus 5, 4, and there it is. I do likewise for minus 4, spits me out 1, I get minus 4, 1, which is here, and so on, so on, and so on. Okay? So hopefully that makes sense. So I can draw a curve from this equation. Okay? Right, moving on though. Now let's look at this. The only difference between this one and this one, okay, if you look at the two equations, okay, so the only difference between this and this is I've added in another 3. Okay, so the x squared is the same, the plus 6x, the plus 9, and I've added in another 3. Right, so what's actually after happening to the graph if I plot it? Okay, let's see. So when I added in the other 3, again I didn't do it here now, but if I put in 5 in for x and worked it out, I get 7. So there's my point, minus 5, 7. So it'll be here. The next point is here, 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 and here. But when I added in the 3, all that actually happens is this graph just gets shifted up 3 spaces. So I added in 3 to that equation, the graph gets shifted up. Okay? What would happen if I minused a number, minus 4? Well, actually what happens is, there's the original graph, but this time I minus 4 gets shifted down 4. Okay, you can see it here. Okay, so we're after discovering then, if we have a graph, if I add a number onto it, it'll shift it up the way. If I take away a number, it'll shift it down the way. Okay? Grand. Keep that in your head now. So, we have in this question an equation, x squared plus 6x plus 12. Okay? So I slot in minus 5 for x and work it out, it'll spit me out 7. So there's 1 point, minus 5, 7. There we go. I put in minus 4 in for x and work it out, I get out 4. So it's minus 4, 4. There's my point. And so on. Minus 3, 3, which is there. Minus 2, 4, which is there. Minus 1, 7, which is there. So there's my graph. Okay? But look what I've done here. I've done my completing the square method. Okay. Now just actually take us back to this a sec. What if someone said, find the minimum point of this graph? If we didn't know how to complete the square method, we would actually have to draw it out like this. And from here I can say, yeah, this is the minimum point, minus 3, 3. Okay, that's the minimum point of that. So from this, if someone said, find the minimum point of that graph, I would have to put in the x numbers, see what it spat me out, draw it, and then say, yeah, here's the minimum point, which is minus 3, 3. But we know an easier way. We know a quicker way. We take our equation, but we're going to make it into an equation that just crosses the x in one place. Okay, so for instance, look at this. Okay, so this is one of these great equations where we only get two answers that are the exact same, which means we have one answer, which means it crosses the graph in one place. So if I could make this equation into one of these nice equations that I know crosses the graph or crosses the x-axis in one place, well, I'd know that this graph would just hit that x-axis in one place. Okay, so that's why I do what I do. That's why I change this around. I make this into one of these graphs that crosses the x-axis in one place. So in this case, I want to make sure that this, okay, can be written as a perfect square. If it's a perfect square, I know it crosses the x-axis in only one place. Right, so how do I do that? How do I make sure I have one of these perfect squares? I have the middle number, and then I square it. So half 6 is 3, square 3 is 9. So this now, okay, I know it's a perfect square. But I can't just add in 9 and just leave it. I take away the 9 again, and I add back in the 12. So this is actually the same as this. Okay, and then when I factorize it out, it's x plus 3 squared. Okay, or realistically, if I was to factorize it the long way, it would be x plus 3, x plus 3. Okay, because x by x is 2x, and then so I'll just do it for you. X by x, x squared, x by 3, 3x, 3 by x, 3x, and 3 by 3 is 9, and that would be x squared plus 6x plus 9. So I've proven that that multiplied by that is that, and x plus 3 multiplied by x plus 3 is the exact same as x plus 3 squared. Now we have the minus 9 plus the 12, which gives me 3. Okay? Now, this is where it's interesting. I know from this graph that if I have one of these perfect squares, it will cross the x-axis if I just change the sign of that. Because look, that graph is actually x plus 3 squared. If I change the sign of that, plus 3, it comes to a minus 3, and look, lo and behold, it does cross the x-axis at minus 3. Now remember, we said if we add on a number to one of these perfect squares, it'll shift it up the way or shift it down the way. Well, look at this. This here is actually one of those perfect squares, so that alone would make the graph hit the x-axis here and go up like that. But look, we're actually adding on the 3. So I know that the minimum value of this must be plus 3. Why? Because that will ensure the graph is like this at 0, but plus 3 shifts it off the way. So I know then it has to be plus 3, the minimum point. If this was a -4 or something, then I know the minimum would come down to -4. Okay? So that's actually how we figure out the minimum point, because we make sure this perfect square will just hit the x-axis in one place, and then we look at the number and see does it push it up or push it down. Now the visual representation of it. Okay, let's have a look at this. So we have x squared plus 6x plus 12. If I was to draw that out, okay, so put a visual representation of what it is. Well, x squared is basically x by x. Okay, so x by x is x squared, so it's basically a box. Plus 6x, well that's x multiplied by 6, which is 6x. Plus 12. Now I'm going to say 12 is the same as 4 by 3. So there's my 12 there. Okay, now look what I've done over here. If you look at this visual representation, okay, I still have my x squared, but I split this in half. And I take one bit of it and I join it on. So I take one bit of it and I turn it this way. So there's that. I take the other half of it and I put it down here. So that's x plus 3 on one side, x plus 3 on the other. That leftover bit is going to be 3 by 3, which is 9. Okay, so that's where I get this from. Okay, so I've dealt with that, that's here. I've dealt with that, that's here. And this 9 then, that's why I added in. That 9 allows me to complete this square. Now, I have this 12. This is over here. So that was a full 12. But now I take away the 9 that I added in here. I take it away from this. And I'm left with 3. And hence why this is actually the same area as that. Okay? And then lastly, have a look at this. X plus 3 is this length. X plus 3 is this length. So x plus 3 multiplied by x plus 3 is x plus 3 squared. And what have I over here? Well, I had 12, but I took away the 9, so I'm left with 3. So this is actually x plus 3 squared, which is that, plus the 3 that's left over. And if you remember, x squared plus 6x plus 12, when we complete the square, it actually is x plus 3 squared plus 3, which is exactly what we've done here. Okay, so that's the magic of it, right? So again, we can just learn it off. We can see, you know, yeah, this is what we do. But I want us to see what we're actually doing, why we're doing it, and what it looks like. Okay, so we leave it at that, lads.